this video, we'll show you how to monitor critical equipment at scale with Elipsa's rapid deployment templates. Through a simple web form, you can configure Elipsa to monitor any type of equipment. In this demo, we're going to use vibration data to monitor industrial fans. To get started, enter your Elipsa username and access key, name your template, and provide a description. Next, enter the list of features or data points from your machine that you're looking to monitor, as well as a prefix to attach to the name of each model as it's saved. Finally, enter the amount of data that's required to build an initial model and the amount of data required to retrain those models over time. Once your template is created, a unique API key is generated. Record that API key for future use later in the demo. With the template now created, we can start intelligently monitoring equipment via our APIs or MQTT. This video would demonstrate the integration with Elipsa via our HTTP REST APIs. To begin streaming data, as detailed in our API documentation, simply record the Elipsa API endpoint, appending the API key generated when you created your template in the previous step. Via a post command, send your streaming sensor data in the JSON format indicated. Elipsa can integrate into any third-party application capable of calling a REST API or sending data via MQTT. That can range from custom applications to popular third-party IoT platforms. In this video, we'll demonstrate how to integrate Elipsa using the open-source Node-RED framework. In this demo, our sensor is connected to Node-RED, generating vibration data once per minute. Regardless of the system, we need to record the location of our sensor data in order to transform it into the required JSON format. In our case, we're using maximum acceleration, and the system stores it under the sensor data object. In Node-RED, we use a function node in order to transform the data in the message payload into the format that's required in our API documentation. The message payload consists of our Elipsa access code, a unique ID or name of the machine that we're monitoring, whether we're sending data in batches, and the current real-time value of the data points that we're set up to monitor in our template. With the payload formatted, we can now send it to the API endpoint of the Elipsa template that we created. Simply send the data via a post command to the URL defined in the documentation, replacing API key with the API key that we recorded when creating the template. In Node-RED, we drag in an HTTP request node. We set the method to post and a return to be a parsed JSON object. Once we copy in the URL, we paste it into the URL field and enter in the API key as recorded earlier. When our sensor next reports data, the formatted JSON is sent to Elipsa. As this is the first time seeing data for the unique ID provided, Elipsa will begin the process of learning normal behavior of this machine. As subsequent data is received, Elipsa will continue to learn normal operation of your specific machine until it receives enough data points to build the initial model. In our demo, we're building an initial model after only 100 data points, but this will differ based on how you configured your template in step 1. Once enough data has been received, the initial model is automatically built without any further interaction from the user. Each call to Elipsa automatically returns a prediction indicative of a future problem, including the confidence in that prediction, as well as the drivers for which data points are driving that decision, all while continuing to learn for automated retraining in the future. To demonstrate, we'll look to simulate failure by changing the fan speed, creating a vibration profile that's outside of what the AI learned as normal. As you can see, a call to the API returns a prediction of an anomaly, along with a confidence score and indication of which data points are driving that decision. The JSON response is returned with each call to the API and can be utilized by third-party systems and workflows for alerting, visualization, and machine control and optimization. Our APIs can make your existing applications AI-enabled. However, the Elipsa platform also includes built-in dashboards for visualizing machine health, as well as built-in alerting functionality for an end-to-end intelligent monitoring solution. One of the key differentiators of Elipsa is that with rapid deployment templates, we truly enable deployment of AI-based predictive maintenance at scale. A single template can monitor any number of like machines through the same API endpoint, simply by changing the unique ID or name for a given machine. This unique ID enables routing and segregation of individual machines, allowing Elipsa to automate the learning, creation, and deployment of machine learning models at scale. Demonstrating back in Node-RED, by changing the unique ID in the payload, we're telling Elipsa that this streaming data is for a different machine than what we've previously sent. Since this is the first time Elipsa is seeing data for this new machine, it automatically starts the learning process, eventually building an AI model unique from the model created for our initial device. Elipsa's simple, fast, and flexible platform enables predictive solutions for industrial IoT.